Going to question 16 now. Here we have an exponent radical expression. And so to make better sense of that, let's review our exponent rules. If you have a to the b times a to the c, that's a to the b plus c. So when you're multiplying, you're adding. If we have a to the b over a to the c, that's the opposite. If we're dividing, we're subtracting. So we have these two rules as opposites of one another. Multiplying means adding, dividing means subtracting. And going to the next one, if we have a to the b all to the c, so an exponent of an exponent, a power of a power, then we multiply a to the bc. And the opposite of that rule is instead of taking it to a power, you're taking it to a radical, then instead of multiplying, you'd be dividing. So these two rules are opposites of one another. The way to really remember this bottom rule is you have the unit of a to the b that's being multiplied by c, or that same unit of a to the b with the c dividing it underneath. So another thing we want to know here is that to make better sense of these things, we should separate them out. So there's nothing wrong with that. 7th root of x to the 9th and the 7th root of y to the 9th. So now utilizing our 4th rule of kind of memorizing which one goes on the top and which one goes on the bottom of the fractional expression, that would have us saying that this here is x to the 9 over 7, and this one is y to the 9 over 7. So we've got x to the 9 over 7, y to the 9 over 7, and we can just go ahead and say that that's like taking xy all to the 9 over 7. Because if we had it in this situation, we could easily separate it back out, essentially distributing that exponent to each part. So the answer here is B.